Başlıyorum hocam, hazırsak. Tamam. Session 4 will be moderated by Professor Mehmet Emin Aydın, Assistant Professor Abdülkadir Taşdelen. We kindly invite them to the stage. This session will address AI governance, educational policy, AI-supported assessment, energy and sustainability, workforce transformation.
Dear participants, welcome to our fourth session. We have four distinguished professors going to be presenting in this session. First, we will have the presentations. Then we will have a question and answering sessions. First speaker is Professor Ercan Öztemel. He is working in Marmara University Industrial Engineering Department. He had his PhD in University of Wales in United Kingdom on neural networks. He is the author of the textbook Artificial Neural Networks. He served as Vice President of National Higher Educational Exam Body, as a Chief Researcher at TÜBİTAK, Turkish Scientific and Technical Research Council. Between 1993 and 2011, he led pioneering projects like Intelligent F-16 pilot simulator and healthcare nurse robot. Professor Öztemel is a key figure in integrating AI into industrial and defense systems in Turkey. Professor Öztemel is member of Tüba AI Working Group. Floor is yours, Professor Öztemel.
Thank you very much, Mr. Chairman, distinguished guests, ladies and gentlemen. I would like to welcome you to the fourth session with the first presentation. I'm going to talk about the impact of AI on education and try to give you some hints what AI is taking us with respect to the education systems. Before I start my presentation, I would like to take your attention to a discussion. AI is coming. AI is came, has came and is already being taken part in our life. It's a part of the society anymore. And it has an impact over every systems, including education. And there are some discussions going on. Is it going to be good or bad? Is it going to have a bad impact in such a way that students are going to lose their thinking capability? Because AI is doing everything. AI is solving mathematical problems, even very difficult ones. AI is even writing software codes. AI is actually generating an essays, an excellent essays. So what are the students going to do then? And these are the discussion going on. But we already know that the education system will not be the same as today. Since it's not going to be the same as today, there will be some positive impacts over the AI. Rather than concentrating on negative impacts, I would prefer to concentrate on positive impacts and try to understand that throughout this 15 minutes talk. In order to understand the progress and evolution of education system with the support or with the help of AI, we probably need to understand what is going on in AI. So just briefly discussing what AI is doing and what is AI and what is AI is doing and how it is going towards the future from the past. AI is the field of computer science that develops systems capable of performing tasks typically requiring human intelligence. This is a very traditional definition anyway. It actually indicates some sort of learning, reasoning, perceiving, understanding, acting, and so on and so forth, like a human being. That's what we are trying to do when we generate AI systems, actually. And when AI is actually started in the early 90s, the people were actually thinking about, would it be possible to have a machine which could behave like a human being? Can machines think, for example? That was the main question in the 1950s. And then logic programming came out, which actually enabled AI to perform logical operations by the computers. And then symbolic representation, symbolic AI, followed by expert systems, try to imitate the behavior of an expert of a certain domain and solves the problems in the same way as human experts would solve when he or she faces the same problem in real life. Then machine learning became very popular because it was difficult to dig out the expertise of the people to generate the expert systems, but it was easy to find out data. When data is found out, and it was possible to get it learned by the computer and generate the results out of the existing data. In fact, it was a kind of some sort of, trying to make it clear, the hidden knowledge available to the people to make decisions. And machine learning, it was going there, but it was not deep up until 2010s and 15s. We were talking about deep knowledge. Once we were able to look at the data deeper and deeper, and it was possible to generate new knowledge out of the existing data, new data out of the existing data, when it is actually possible to get it integrated with natural language processing systems, and it was possible to get the generative AI. Now, generative AI is generating the knowledge. It's not only predicting or finding out what the knowledge and hidden knowledge is inside the data, it always generates the new data out of that. Now, there is a problem. Expert systems were very good in explaining why and how they make decisions, but generative intelligence or machine learning systems are not capable of making that particular explanations regarding the reasoning process. So explainable AI, and then following that, artificial general intelligence, and going towards the artificial responsible intelligence, so on and so forth. Okay, it was an imagination in 1990s, and then it became a scientific inspiration for the scientific communities to generate a humanoid robot. Then it became a problem-solving tool in 1990s, and commercialization is started. And followed that up until 20s, and it became a human-aware intelligence, followed that with a social integration. That means AI is with us anymore. It's going to be part of our life. I am not going to be surprised if the people, my grandchild or grandchildren, will be following or running in the society together with robots, okay? And it seems that human and robots are going to be collaborating in the coming futures after 2030s, all right? So what happened during this time? There were 8 shifts. One of them was actually we were going from programming to learning, from reasoning to prediction, from symbolic reasoning to latent spaces, from discriminative information to generative information, from using tools to agents. Oh my God, from transparency to opacity, and from human-centered approaches to post-human approaches, and obviously optimization, which is a very popular topic in 1980s, 1920s. Now it's becoming a kind of an alignment processes. Because it's not going to be easy to find optimum solutions for every kind of problems. We were always doing that like that, isn't it? This is the capacity expansion. I'm not going to spend time on this, but I put it into the slides for your own information, how it is actually expanded the AI programs. Okay, let's look at the AI impact over the education then. And there are some methods and methodologies and tools which are developed within AI community, which would have a great impact over education systems, like autonomous robots, like, intelligent networks, smart data analysis, cloud computing, cyber physical systems, additive manufacturing, simulation. Now we are talking about virtual labs instead of physical devices, spending too much money. You see, just we actually generate the virtual labs and get the same feelings to the students, and so on and so forth. And educational transformation is also followed with the evolution of AI. Let's look at the educational transformation. Pre-industrial study, there was an apprenticeship. The people were actually trying to learn through the observation or demonstration. And then when the industrial society became the reality, the human people, the education system is emerged to actually generate mass knowledge transferring systems, to actually transfer the knowledge to the students. And students were passive receivers, and the teachers or instructors were the central source of knowledge. And with the, information technology development and the industrial age, society emerged, then we have education factory. The students, the universities and the schools became a factory producing students. Students were the product of the schools. That were actually, the instructors were actually evaluating how good the students are, rather than just, transferring the knowledge. They were transferring the knowledge, but they were also evaluating how good the students are actually. And standard curricula and exams and grading were becoming very, actually, intensive applications within an education system. And towards the 2000s, with the early digital society, we see the computer-assisted educations, where the teachers are actually playing the role of being facilitator rather than just an evaluator or transferring the knowledge. And the students were actually active learner with the support of computer. And then actually multimedia, computers and software become the key tools for educational activities. And then AI came into the play, digital network learning, and students as a producer, and internationalized higher education. That's actually how it is going towards from now on. Okay, with the help of AI, it was possible to generate like sort of creating new knowledge out of the existing knowledge. Then the students were actually getting to know how to generate the knowledge rather than just actually getting the knowledge from the instructor and implementing it. And it goes actually towards the globalization, and the students are going to be some sort of international collaborators. Bologna process, Erasmus algorithms, and accreditation processes are becoming more and more popular nowadays. Okay, this is the philosophical shift in education. We have to really understand this. This is important because classroom learning is leaving its place to ubiquitous learning. That means you can learn everywhere. You don't need to go to the classrooms anyway. Standardized education curriculum is leaving its place to personalized, customized education. Memorization is leaving its place to competencies. The students are not only memorizing anymore. Memorization is not going to be help. They have to develop their competency in a certain areas. Fixed curricula is leading to lifelong learning, and exams are actually not enough to check out the competency. Instead, we are looking for continuous assessments, and the knowledge users and students are now becoming as knowledge co-creators and producers. Isolated learning is going to globalization, and traditional tools are leaving its place to AI tools, like, you know, augmented reality, virtual reality, and smart analytics. When you actually combine these with AI methods and methodologies, you are having an excellent learning environments and so on and so forth. Eventually, as I said a while ago, we are trying to go to human and AI synergy in education. This has to be coming on anyway. There is no way to avoid it. Unavoidable. Okay? New educational approaches, experiment-based learning. You are not teaching the students how things are going to be anymore. In my class, my students are learning everything before they come to the class. On internet, everything is there, but they don't know how to apply the knowledge. We try to implement through case studies and try to get a good comprehension of what the knowledge is going to be having an impact. Distance education, assessment-based learning, project-based learning, eventually, and it's going towards the agent-based education. Now we are at this stage. Within coming 4 or 5 years, we will probably have agent-based education implementations, but after 2030s, this is for certain, to my understanding. I'm pretty sure that virtual mentorship is coming. 7 days and 24 hours available. That means we are going towards teacherless education. Okay? I'm sorry for the teachers. I am a teacher as well, so. Yeah. The learning, teaching, assessment, content, collaboration, accessibility, skills, technology, and role of the human within the education systems are changing. We shouldn't worry about that the students are going to lose their capabilities, because they are not going to be, they are not going to need the same capabilities that today's students are acquiring or requiring. They will have some sort of other capabilities which would be based on the things that are being generated by AI systems. So the thinking capability will actually change its pace, to my understanding. Okay, this is a brief comparison between traditional education and AI-supported education. Teaching model is going from one-size-fits-all to an instructor-led situation to adaptive pathways and customized learning. Role of instructor is actually turning from being the center or primary source of knowledge to the learning designer. Students are changing from passive recipients to active and self-directed learners, and content delivery is also changing because of the customization. Okay, fixed lectures and static materials are leaving their places to dynamic AI-generated and continuously updated materials in accordance with the technological progress. Anyway, okay, assessments, instead of exams, we are having AI-assisted evaluations, which will be mainly based on checking out the skills and capabilities. And you see feedbacks, scalability, content creation, human-developed materials are leaving their places to AI co-created with instructors, and so on and so forth. Support is given 7 days, 24 hours without any interruption. Today, I have in my door a schedule I am available from 9 to 11 every Tuesday for the students to answer their questions. Only Tuesdays and Thursday, 1 hour, 3 hours a day. I am sure all of you have the same, but in the future, mentors, virtual mentors, AI lecturers will be able to provide support every time. Okay, real-time plagiarism and anomaly detection will be main issue with respect to the academic integrity instead of manual monitoring. And it will not be easy to actually copy the things and, generate the reports. I have found a paper which is being published in Iran, exactly about the title, everything is exactly the same with one of my previous papers. Exactly the same. I made a mistake in one page, Hocam. The mistake is still there. They didn't even, read it once to correct it, right? That's actually, I don't know what happens, I have no control over it. But as a man, I just came across by chance. But it is, AI is not going to actually let these things to happen anyway. Okay, as a conclusion, we are easily saying that AI is having a great impact and turning the education system is from classroom to ecosystems, and it's transforming into flexible, personalized, and lifelong digital ecosystems. And the students are becoming producers rather than consumers, and they evolve from knowledge consumers into producers and problem solvers and innovators. And teachers are actually shift from the knowledge transmission towards mentoring and learning designer. Lecturers are not going to be lecturing, but designing how the system is going to be supporting the students' learning capability. How can we have a customized learning which would be very beneficial to the students and so on and so forth. We will be spending our times more on those. Not me though, because I'm getting retired soon. Human-AI coexistence is inevitable. The future is a continuously evolving data-driven ecosystem of human and AI collaboration. Universities will become interdisciplinary, innovation-driven, globally connected institutions supported and supporting lifelong learning activities and so on and so forth. Thank you very much. Did I finish it in 15 minutes?
Yes, thank you very much, Professor.
I was told several times to finish it in 15 minutes, so I had to be a bit quick. Thank you very much. Thank you very much.
Now, our second speaker is Professor Yusuf Sinan Akgül from Gebze Technical University, and his topic is From Threat to Tool, AI integrated assessment as a solution to two problems at once. Professor Yusuf Sinan Akgül is working in computer engineering department in Gebze Technical University. He had his PhD in computer and information sciences from University of Delaware in 2000. His research area includes deformable models, graph cut optimization, medical image analysis, human action reorganizations, and object detection. He has led interdisciplinary projects such as an intelligent home-based physiotherapy exercise monitoring systems. Professor Akgül published extensively in top journals and also holds several US patents in optical inspection and video summarization.
Thank you very much, Mehmet Hocam, for the nice introduction. Ercan Hocam, that was an excellent talk. I mean, I value his opinion a lot. It is my presentation is going to be like this. I never talked to him actually. It looks like my presentation. I listened to Ercan Hoca. I studied his lectures, I went home, I designed something, and I'm coming back to Ercan Hoca. Ercan Hoca, is this okay? I mean, just give me a grade. So this is after I listened to your talk, and I designed something, and I'm applying it. So from Threaded tool. By the way, I used some AI tool to prepare this stuff. I guess you use the same stuff too. So this presentations are very similar too. So from Threaded tool, this is going to be a very concrete example. This is just my experience that I got this semester actually. Some of these results are actually students are using. I'm going to, after studying what Ercan Hoca said, I designed something like this, and I think it's starting to look like it is doing something. So this is briefly, Mehmet Hocam already told about me, but this is the related part. I teach computer science for the last 20-25 years. I try to teach very basic stuff like introduction to computer science, C programming, C++ programming, and programming languages. So when after this, I've been working on AI topics starting from 1990s. But I mean, when you realize that this technology is so big, it is so different, it can be used to address many problems in our higher education, we started talking about this, thinking about this, and we started developing our own solutions, okay? And today I'm going to present one of them, our proposed solution. So two things. Our approach is usually, I think this is, may I? Too much. Really?
They will open this.
Okay.
Close it, they will open here. Please. Here is another one.
It is fresh, with the fresh air it comes the noise. I don't know. I think I will hide behind this. You will have your fresh air, I will have mine noise free. Maybe, yeah. Is this okay? Is this okay? Okay. So we found a solution, yeah. Academicians are working, yeah. Good. Okay.
Dear Professor.
Yeah, well, yeah, we try to find solutions, yes. Sometimes we do. So, our approach is, I mean, in Turkish academia, let's not hide it, we have many problems, okay? Lots of problems. And trying to solve those problems one by one doesn't work, okay? Every time you solve a problem, another problem comes in. I mean, we had this problem of people are not publishing enough, so we said that we are going to give you awards if you publish enough, and people started doing some fake publications and that kind of stuff. So, I mean, handling the problems one by one doesn't work, so we are going to do this exponential solutions. Come up with a solution that will address more than one problem. That's what we are trying to do. One of the problems that we see, Ercan Hoca kind of talked about it, we don't trust AI because when we assign a project to the students, what does the student do? They go to AI tool, ChatGPT, they type my homework, and ChatGPT produces an exactly perfect 100 score homework back to me, and it is original. And all I do is give 100 to student didn't understand anything. So the first problem is this: AI threatens the assessment integrity. Students superficially they use AI. So the meaning of homework is not there anymore. They don't do their homework themselves. If the student is very honest, he or she feels that they are getting behind. All the other people are doing this AI-based homeworks, and they are presenting that as their own. They are not learning anything, but they are presenting as their own. So that's a very big problem for us. That's one problem. The second problem is that this is the one that we have all the time, actually. Everybody's having this. I know people, they are very slow to start learning something, but when they learn something, they are like big trucks. They carry lots of work. This their nature. I am a fast learner, but I give up so soon. Okay, that's my nature. I can't do anything about it. I am more than 50, I'm 55 years old. It has been that way for the last 50 years. I can't change it. I learned it that way. You can't force people to listen to the same professor to get the same knowledge out of it in the same way. It doesn't work. So people have been arguing about this. Education must be customized to each student. It should be personalized, and etc., etc. But we never did it. Okay, we never did it. So we say that we are going to take on these problems both at the same time. We are going to say that we are we are going to use AI for our homeworks, for all the work in the classroom, and projects and everything. In the meantime, we are going to address this problem too. So both have been interactive problems separately, and we have a kind of a solution, and we think that it kind of works. One tool, both answers, okay? The same technology that created problem, one turns out to be the answer to the both of them, okay? Some people, I don't know about that, I never agreed with them. They say that let's ban AI, okay? That will never work. I mean, we weren't banning the calculators, we weren't banning the internet, I mean, the banning doesn't work. I mean, if the technology is useful, they have to use it. We should find a way to prevent using it in an unethical way, in a superficial way. So banning altogether doesn't work, okay? And even if you ban it, if it works, the student has to use AI tools after they graduate, right? I teach computer science, computer engineering. I can't imagine any student getting a graduation degree from me and not using AI in their work. They have to do it. That's why I have to teach them that way. You are going to use AI to write code. You are going to use AI to develop projects and etc. So it is unenforceable. It is not realistic. So you are not going to ban anything, okay? Let's ask students to use AI certain ways, but not the other ways. If they use it some certain ways, bad ways, let's detect it. No, it doesn't work. Detection doesn't work with the AI because it's an arms race. I write a nice detection tool, they find another way to circumvent it. So that's not going to work. It is arms race, detection is not going to work. And some people say that let's do it all AI-free stuff. Again, handwritten exams, they are nice. Oral defenses, I'm going to give you a demo. You are going to make me a demo. I will detect if there is an AI. So that doesn't work either. So none of these problems address problem 2 at all, and problem 1 is still there. So this is our solution. We say that AI is not an option. AI is not something to ban. You have to use AI. Okay? It's like in 1990s, in 1980s. I remember when we write an essay or something, it has to be written somewhere, right? The professor used to force us saying that you are going to use a word processor to write it. Using a computer to write an essay is compulsory. They force it, right? So we are going to force them to use AI. You are going to use it, okay? It is not an option. That's one thing. And then we will verify if they used it superficially in an unethical way. That will be the second phase. And so this is how we are doing it, okay? First, require AI use, and we are saying that, okay, you will use AI, and you have to use AI. Second, you are going to document it. So how you interacted with your AI tool, ChatGPT or Cloud or Gemini, you are going to submit, along with your homework or project, your chat documents, your chat transactions as part of your homework. So I am going to see how you communicate with your AI tool. Nowadays, of course, we are using ChatGPT or Cloud as the AI tool. My proposal here is either the Ministry of Education or Higher Education Council or my university would come up with our own AI tools, and we are going to use this AI tool. I am going to document everything there with your interaction. That's part of your work, and I am going to see how you are interacting with the AI tool. Students are saying that, okay, how am I going to do that? Well, I mean, when you interact with ChatGPT, it can be documented, right? It has timestamps on it, and it is like hundreds of pages sometimes, the documentation. That's okay, because when I grade it, I will use AI tools too. And after that, after they worked on the project for 2 weeks, they come back and they submit their projects. As expected, it is all perfect, right? Everything works because they use AI tools. But I give them a personalized exam, handwritten exam in the classroom, maybe for 1 hour or 2 hours. I think I'm going to do it for this Thursday. I'm going to do it for more than 140 students. Each one has their own personalized, custom-made exam. The exam says that you said you did use this and this, why didn't you use this? If I change this parameter in your homework, what would happen? Okay, now I'm going to give you an example and do this example like you did in your exam, in your homework, in your project. Okay, that's the personalized exam. Of course, somebody, I mean, the class that I'm teaching this semester is more than 100, I think there are 170 people, but only 140 are attending the classes. So I'm going to produce 150 exams, and of course I'm going to grade them using AI, or I'm going to prepare them using AI under my verification. And I will verify the result without AI. That means students has to come into class and write something on paper. I like them write something on paper because writing things on paper has something with it. I don't know who invented writing. It's a good invention, a perfect invention. It just touches somewhere in your brain. Writing and reading what you wrote is something different. So even though this is a programming language course, I really like students write things on the paper and we grade them from the paper. So this happens what? AI integrity, they can't just submit whatever the AI tools give them because I'm going to verify it. When I verify them, I don't verify them the same way. I verify them according to what they gave me. It's a customized exam. And although we didn't do it yet, I like to put in more questions like, this student seems like he doesn't know this topic yet, and maybe I should ask him a few more questions about it. If he doesn't answer it in the next exam, I will ask more questions. If it doesn't happen again at the end of the semester, maybe I shouldn't say you failed. Maybe I should say, okay, you go on with your next course. In your next course, I'm going to ask that kind of question again. So customization and grading will be something like that, okay? So why this solves both problems at once? Superficial AI use becomes self-defeating. If the student submits something that he didn't understand, he wouldn't get a grade. Okay, because that in-class exam is an important thing, and personalized assessment really asks the questions about what is important to the student. Okay, so AI just is not a disease in this case. It solves two problems at the same time, and that's how we should approach new technologies. Are we solving more than one problem that exists? Don't make the new technology a new problem. Okay, nowadays I keep hearing it. AI is the new problem. How are we going to solve these problems? So AI is not a problem. The way we use AI is a problem. So use the AI to address that problem, also some other problems that kind of became our DNA stuff. Okay, I have 170 students. I do a handwritten quiz every week to all of those 140 students every week. Half an hour quiz, okay? As Ercan Hoca said, I am not teaching much actually in the classroom because my Cloud and GPT is always open. Cloud and GPT always, they answer student questions better than me. I am kind of a mentor, I am some kind of a guide in there. And the students are creating their own stuff actually. They ask interesting questions. They ask about the history of the programming language, and I tell them, don't ask me, ask your AI tool, okay? And every week I make a quiz, and those quizzes again, although these are the same quizzes for everybody, maybe later I can change them too, because it is not that difficult. And they are graded, of course, automatically. I'm going to show you my, my grading tool, AI-based grading tool. So this semester I assigned this project. Project is, you will design your own programming language. You make a decision on the domain of it. That's a domain-specific programming language. You make a decision on it. You are going to justify me why you chose it. Okay, your design document. Yeah, then you are going to write a parser on it and then an interpreter on it. But everybody should have a different project, right? They should be all different. And I will give these two personalized project exams, and that project exam is one of the main components of the grading. Okay, so the critical part is exam references the student's specific design choices, not generic textbook concepts. Okay, student submits, AI produces a generic exam for each one. We print them differently for each student, and we hand them out. This is your question, and this is your question, and et cetera, et cetera. Student does the handwriting, AI grader grades it and we verify it, and I will show you how we the demo. I would be glad to show you I brought some demo. It is in my laptop. If somebody likes to see it, I can show it to you. This is one example, personalized exam. I redacted the student name and the number. Maybe you can't see it from there. Okay, these are some of the questions, okay? It says that your D1, the part 1, 4.3, grammar uses indent, detent, okay? That's how the student, the question starts. And it continues, why did you use that instead of this one? The student has to answer it. Trace your D2 lecture on this input. I am going to give you a new input. Does this work? Yeah. Does this? No, it just, so that part of the thing, yeah, it just swallows everything. So that part of the thing is just, I am going to give you your programming language. I am going to give you this input. Just trace that input for me, okay? So nobody in that class, other than that student, can do this question, okay? Nobody can do it, that question, and they are doing this in class. Of course, somebody has to grade all of these. It's a lot of work. This is what we use as the grading tool, okay? On the right, we have the students' handwriting. They write in special boxes, nice space place. And we do OCR, and after OCR, we grade them. We say that this is our rubric table, and this is what you get. You say that the student got 10 out of 20 for this question, and those are the reasons. And then as an instructor, I have to verify it. I think it is visible. I verified a few of them out of this. We had batches of 30. I verified them one by one. And I click on what is verified, or I override it, I change it, I put some remarks on it, and all of this information is sent to the student by email. So the student knows what grade they got, and why they got it, what the mistakes, and etc. So usually with this kind of stuff, this course is 6 ECTS, lots of work. 6 times 25 ECTS, so we are expecting 200 hours of work per semester for this course. And students are really filling in all those hours. And previously, I used to tell them that study hard. What should I do? Read the book. That doesn't work. I mean, the people don't read books anymore for the last 10 years. They don't read it, okay? So they don't know what to do, actually. I mean, how would I spend 200 hours for this course and get a passing grade, nice passing grade? Now they know. Every week they have a quiz. And by the way, the quiz questions are prepared using the AI tools again, and I send them the prompt that prepares the quiz question. So they prepare their own questions, they answer it, and they do infinitely many number of, they can do infinitely many number of test exams for themselves. So they seem like although they are doing lots of work, they seem like happy. And how do I know that? I run a questionnaire. I ask them, what do you think about, are these explanations clear and satisfactory and they are fair? I never get these kind of grades out of a student, actually. I mean, all the time, my grades are 2 out of 4 at the end of the semester. As a dean, I send an email to myself saying that your grades are too low. Please find a way to improve it. So I am one of the worst performing instructors of my faculty. Nowadays, I am doing better, okay? It is not because I am giving all A's to them. It is because people think that they are doing something, okay? It is 340 personalized projects, exams. They will be graded. And our claim is 0 superficial use of AI, unethical use of AI. My workload, am I doing less work? No, definitely, lots of work. I have to watch them, lots of many people, and I have to verify these one by one. I have to read these actually, but I don't make those small mistakes because, I mean, if you are, I mean, I'm sure as professor you have graded, I mean, this is Turkey, right? In government schools, my school enrolls more than 100 people every year. Some of them fail, and our classrooms are like maybe more than 200 people. Either you are not going to give any homeworks, or you are not going to do an exam, or we are going to grade them manually yourself. Now I'm feeling that I can handle maybe more than 200 or 300 people. And I have only 1.5 TAs for this course. Okay, so let me, how am I doing with the time? I started, oh, I am 3 minutes over, sorry. So this is not an MIT solution. I did it myself with the help of two TAs, and everybody can do this. And we solved 2 problems using one tool, and we applied whatever Ercan told me like 5 minutes ago. You are not a professor anymore. You are not going to teach. You are a mentor. You are a abi abla in Turkish. Okay, because these tools, they know better than you. They can explain better than you. Well, your job is to keep them stay on the railroad. Okay, don't let them go anywhere else. Okay, your target is that, and you are going to stay locked on your target. You can learn anything that you like, but I am going to ask you this. So I become like a mentor. And I am like it. Of course, this is not all free of problems. There are many problems. I don't know what I am doing with. I mean, when I show you this, maybe this is not right? I mean, this is students' private paper, and I'm showing you this, and this is, those stuff. But I trust you wouldn't tell anybody else. Okay, Muzaffer Hocam, please don't tell this to my rector. There are many problems that we need to solve. But without solving these kind of problems, we are not getting anywhere. This technology is amazing, not like that we have seen for the last 100 to 100 years, but we have to use it right, and we have to use customized, especially for countries like Turkey. Thank you very much.
The title was supposed to be from tool to thread. Anytime your presentation, this is what I have found.
What is the trend? I didn't understand the question.
Really big challenge.
Oh, yeah. It's a challenge.
Yeah.
Well, our big technologies require they produce big challenges, and we have to take those challenges, otherwise we are doomed.
Thank you very much, Sayın Hocam. We will have question time at the end. Now our third speaker is Professor İbrahim Dinçer. His topic is global perspectives and innovative energy dimensions and AI options. Professor İbrahim Dinçer is a professor of mechanical engineering at Ontario Technical University and Yıldız Technical University. He is a world authority in sustainable energy technologies, thermodynamics, exergy, hydrogen energy, and energy storage systems. He has authored over 1,400 papers, cited more than 64,000 times. Professor Dinçer serves as editor-in-chief, multiple top journals. He is currently president of Hydrogen Technologies Association, chair of Energy Working Group of Turkish Academy of Science also. He has been consistently recognized as the most influential scientific minds and most highly cited researchers in engineering.
Thank you, Mr. Chair. Good afternoon. Good afternoon, everyone. So the talk is going to be really about global perspectives on innovative energy dimensions and AI options. So we'll provide both in a combined manner. So I will try to, of course, keep some of my slides to make it really more efficient time-wise. So really, I like to highlight a couple of things. This is one. Research, innovation, and commercialization. This is something very critical. We need to take research really one more step ahead, really do innovation, and also into commercialization where we can really create value. So the concept is going to be very critical in energy research. So the equation I make out of this is going to be really coming down to technological success is going to really cover research, innovation, and commercialization. Imagine the formula is going to be this way. When you have research 1, innovation 1, commercialization 0, and the end result is going to be 0. So it is really critical to make it by including all 3. So efficiency similarly can be defined, and as you see here, by tangible technologies divided by the inputs. Inputs may cover, of course, financial to human capital. So really, in this case, I like to say, really, in order to create innovation-based economy, really coming down to human capital, and that is what makes innovation-based economy. So similarly, I define the welfare cycle for a country coming down to research, innovation, and commercialization. Really, end of this is going to be really with the technologies. Later, of course, end result is going to be, of course, more economic activities, greater prosperity, and finally, better life for people. This is to illustrate, based on UNESCO's data, so when you look historically what happens, really energy consumption increases. And in the future, of course, this is going to even increase more. So we need to keep it in mind and proceed to the next to be able to see carbon dioxide emissions. And this is something very critical. I compared, basically 2 years of data, and what you see over here, and based on the data in 2023, and energy sector contributed about 68% globally for CO2 emissions. When you look at the report year after by the United Nations, what you see, so the contribution has increased to 73%. Based on decarbonization efforts, what you see over here, instead of ending up with some reduction, we end up, of course, with some increase, and this is really drastic, by 5%. So what is really critical and needed in this regard, and really we need to change our energy diet. So this is something what we do personally. We change our personal diet, but it is coming down to really we need to change our energy diet. So waste valorization is going to be very critical. We need to keep it in mind. Why waste? And waste is really a source. You know, sometimes we ignore, but we shouldn't ignore, is like renewable energy sources. So very critical. I like to emphasize this. You know, when you look at the energy equation, what we have in energy equation, really we have three key players: fossil fuels, renewables, and nuclear. Imagine now, fossil fuels will be phased out, so who is going to be coming into this? Hydrogen is coming into this equation, so this is something we need to keep in mind. Also, we need to keep in mind people need really certain commodities. Imagine, people need clean air, clean food, clean water, and clean energy. If energy is not clean, what will happen? The rest is going to be greatly affected. So making a clean energy requirement a prerequisite. Clean energy solutions will come down to renewable energy technologies, hydrogen energy technologies, clean green fuel technologies, efficient energy utilization, cleaner technologies for fossil fuels, energy storage technologies, nuclear energy, waste to energy, of course, is going to be critical. And also everything is getting integrated. So where we need system integration, also we need AI coming into the picture. Also, this was clearly to illustrate that, you know, carbon age has ended technically by the coronavirus pandemic. And I had this article to illustrate that. So this was a kind of turning point, really, where hydrogen age started. And this is clearly also seen when we look back historically what has happened, what humanity has used, started with wood, later with coal by industrial revolution, later by oil, natural gas. When you look at carbon-hydrogen ratio, what you see, a clear indication that we are moving into a carbon-free society, and that will be really built on hydrogen. Hydrogen is going to be playing critical role as a fuel, as an energy carrier, and more importantly, as a feedstock, key feedstock. So that's why it is hydrogen 1.0, And this is also going to be illustrated this way to be able to show really the historical periods of economic development. So when you look at the scale, economic impact factor, and what you see, we, of course, after the Second World War, we had the labor-intensive era, and then followed by, of course, by 70s to 80s, skill-intensive era, later by 80s, capital-intensive, by 90s, technology-intensive, by 2000, innovation-intensive, by 2010, digital-intensive, by 2020 is really into hydrogen-intensive era. So when we look here, now what we see in this era, we need technology, innovation, and digitalization really in a combined manner and making it really critical, a kind of four-leg. And then also we need to check to see, you know, in innovation in hydrogen technologies really is going to require bringing parties or stakeholders from academia, industry, and government agencies together for this transition. And to look at the artificial intelligence, so in every field, of course, in my case, I wanted to bring it down to really in the field of energy, what we specifically do, and we have, of course, these tools, not yet a threat to us, and when we look at this, Internet of Things, you know, really having this, you know, controlled, managed, and properly optimized by using Internet of Things, physically sensing and connected devices and managing it in a smart manner, and also at the same time going to the next digital twins, giving us an opportunity without even building a plant to manage it really by developing a virtual representation and simulation. And imagine, instead of really spending so much and investing so much, so we'll be able to manage it through digital twins. So only the way to be able to create the really the simulation, design it accordingly, simulate it, represent it, and really optimize it. So the next is going to be really to look at the machine learning, and this is becoming very critical. And especially database prediction and decision support is really critical. I will be showing some examples as well. And deep learning even getting into a kind of more advanced patterns recognition and using data and training the systems and managing and controlling the systems really make this field unique with these tools. Having said that, you know, here are some examples. These examples, as we have been working on, and we see really clear advantages of using such tools and Internet of Things, we see, especially from renewable energy monitoring. So you have, of course, really systems all around, especially renewable energy systems, onshore, offshore, and when you look at them, you know how to monitor them. So this monitoring is going to be very critical. Next, asset monitoring, again related to energy systems and applications, smart metering, grid monitoring, and you look at, of course, the way we develop our really energy management applications, where we have really now more smart way of checking and controlling, you know, energy systems in buildings and houses, so becoming very important. Similarly, coming down to energy storage monitoring, and also EV charging, and you look at fault detection. So all of these now managed through the internet. So becoming very critical. And also in here to look at the digital twins, you know, as we are able to really design our systems without building, and to be able to really see what will happen and managing them accordingly, so becoming very critical from renewables to power plants, carbon capturing and storage systems, energy storage, maintenance, hydrogen technologies really coming down to electrolyzers and fuel cells, and extending to buildings and even the nationwide to grids. Machine learning is going to be really giving us better opportunities to manage, numerous operations, and also giving us opportunity, of course, managing forecasting, monitoring, and control as well. So demand forecasting, renewable forecasting, price prediction, predictive maintenance, fault classification, consumption analysis, battery health. So really to be able to manage and also optimize accordingly, and really this way we better control, manage, and optimize. So the final is going to be in here to look at the deep learning. Deep learning is going to bring also various dimensions, really opening the horizons for the area where we have really energy systems and applications. And you see here, basically covering thermal inspection, vibration diagnosis, solar forecasting, load forecasting, battery degradation, visual inspection, power quality. So all these are, when we do advanced training, accordingly to be able to manage them for these energy systems and applications. So since time-wise we have a bit, so I like to go, probably a couple of slides to illustrate and a couple of things to finalize my talk. So after that, we need to look at also life cycle emissions. We have been conducting life cycle assessment studies to look at the emissions as well. So I have these three examples here. What you see, gasoline vehicles, of course, emitting over 150 grams of CO2 per kilometer driven. Always people ask, how friendly they are to environment. And look at the battery-based electric vehicles, 20 to 30 grams of CO2 per kilometer driven. When we look at the green hydrogen-based electric vehicle, 2 to 4 grams of CO2 per kilometer driven. This is really to make it and to illustrate that hydrogen vehicles will be really more critical. So hydrogen ecosystem is going to be critical, and when we look at this hydrogen ecosystem, we really need AI tools in every segment, from production to storage, transportation, and distribution, and then all the way down to hydrogen utilization. And when you look at this ecosystem, what you see really becoming a carbon-free ecosystem. And then some examples related to hydrogen hubs, farms, villages, and valleys. So these are also important. Hydrogen region developments, these are also coming down to specific applications where we really need AI tools from source to service, basically useful outputs. So I like to close. And these are, maybe in another occasion, since we are running out of time. And I like to really close by saying, when we look at, we are in a hydrogen age. And hydrogen age, basically hydrogenization is becoming very critical if you want to achieve decarbonization. And when you look at here, of course, I have these 9 steps. The first step is going to be really coming down to human capital development, basically education and training. Next is going to be research, innovation, and technology development. Next, policy and strategy development with an action plan, followed by sustainable funding and support, followed by infrastructure development and capacity building, and also next is going to be ecosystem development, business development and value creation, and ultimately targeting to achieve sustainable wealth and prosperity creation. So finally, to keep in mind that in this age is going to be really critical to bring all these three players together: innovation, technology, and digitalization. So what will make it really critical? So I like to stop here without taking much of your time to be able to switch to discussion to give basically more opportunities for Q&A. Thank you. We have okay. But anyway, I made it in 13 and a half minutes.
Yes. In our session, the last speaker is Professor Halit Yanıkkaya from Gebze Technical University, and his topic is from automation threat to deep complementarity, the polarization of AI use in occupations in Turkey. Professor Halit Yanıkkaya is professor of economics at Gebze Technical University. He received his PhD in 2001 from the University of Delaware. He is associate member of Turkish Academy of Sciences. His research area includes growth economics, development economics, international trade, global value chain, instructional economics. Professor Yanıkkaya has an extensive publications with a lot of citations in leading journals such as Journal of Development Economics, World Development, and Economic Modeling. His recent research explores the implications of GVC participations for sectoral productivity, technology exports, and environmental outcomes.
Thank you very much, sir.
Hocam buyurun.
Good afternoon, everyone. Let me start with this. The AI is kind of general purpose technology, and this is not the first time that we have seen the technology affecting our life from top to bottom, every kind of society, occupations, every economies and everything. So we have seen those changes in the during the time for at least last 200 years. But this time is going to be like unprecedented effect on our societies, how we work, how we do certain tasks, or what kind of skills that we need actually. So in this case, there is a general purpose technology coming to us, and we have to adapt those technologies. So in this case, just considering the effect on the society, especially on the labor markets. So this thing going to, since our occupations, our jobs, our tasks are highly exposed to AI, so AI expect to affect us basically in three ways. Either is going to us more effective, more productive, or somehow destroying our jobs, or create newer jobs that we haven't seen at the earlier times, so we have to change our skills and abilities to adjust the newer technologies. That's the main idea here. So this is a purely empirical work. So I basically try to understand that what are the effects of AI adaptation in Turkish case, considering the demographic factors, certain digital infrastructure factors, and certain occupational characteristics. These are the contributions that I'm going to skip it, because basically I'm going to show you the result, regression result. So in the especially effect of AI on labor markets issue, the earlier studies are mostly macro studies, considering the countries, considering the R&D systems and patents and all those things, whether the countries have certain digital abilities and what kind of effect on the labor, employment and growth, so on and such. These things, but the macro studies is not suitable to understand what's going on in the micro data, what's going on in the actual occupation or actual task that we have to change, we have to adjust to the new technologies. So basically, there are a lot of micro studies, and they somehow develop certain indices to understand that what kind of occupation or task are exposed to what kind of AI technologies and those things. Basically, task-based indices are heavily developed in the literature, and most of them are studied on the United States, European Union, and certain countries. And in this paper, in the first time, I'm basically what are the AI occupational exposure on the Turkish labor market. So our basic data sources is the household individual ICT survey. This is available since 2005, but the AI questions are only available at the latest release. So this is a cross-sectional data. I might have to say that I cannot claim any kind of causation analysis in this case. Just we have to say that this kind of associationship or some kind of correlation that we can claim, at least at this point. So this is the question as you see in the survey. Have you used any generative AI tools? If you say yes, is 1. If you say the last 3 months, if you say no, this is 0. And if you say yes to generative AI use, you're asked what purposes that actually you use, like personal, educational purposes, or some kind of job-related purposes. So this is the basic, as you see, this is the data. You might see that this actually have 25,000 individuals, but I only take the sample who has the occupational data, ISCO codes, because without the occupational data, I cannot say anything about it. So as you see, is the 70% are male, which is exactly the same in the Turkish labor market. The labor force is the 7% male. Average age, 40. Household ICT access, this is the variable that I created. If you have a computer, laptop, some kind of tablet, all those types of infrastructure units, you have the ICT access. Digital skills, there's a 9-question set in the survey asking for you the certain kinds of digital skills. If you have this one, otherwise 0. Education, you see that almost half of them are high school or vocational school graduated. Income group, mostly represented in the top quintile. The AI use, 20% says that I use AI at the last 3 months, and 16% personal use, 10% professional use, and 4% for educational uses. Then I take this ONET database, and I'm sure who are working on the labor market knows this database. This is the United States Bureau of Labor Services created those definition and described for the United States. So there are 41 tasks that describe the over 900 occupation in the United States. So one of them is thinking creatively. So whether any occupation needs any kind of requirement to do its job, thinking creatively. So it is a score between 1 and 5. As you see, the higher score one, the architecture, copywriter, fashion writer, something like this. The lowest scores goes to the data entry keepers, assembly line workers, those things. So we have, by using these data, these codes, I have calculated the created score for the Turkish occupations. Then, using the same data for almost 900 occupation, 41 tasks, different tasks. Let me see, this is something like this. These are the 41 tasks. These at the left, you see high exposure task, medium exposure task, and the low exposure task. This is it. And in this case, for the Turkey, the contract salesperson is the highly AI exposed job, and the electrical engineers at the top, and we have almost 300 occupations actually ranked by this index. So then I calculated the exposure index, high, medium, and low for the Turkish labor markets. And basically, using this methodology, probit is either 1 or 0 if you use AI or not use it, given the creativity scores between 1 and 5. So at the earlier technologies, you will see that technology mostly affected certain tasks. Those are automated, and those people are most likely to be the low-skilled labor. But the new cases, for the AI cases, mostly white-collar people, highly skilled people are more expected to affected from this. So basically, creativity scores is mostly seen in the high-skilled labor. And AI scores, as I said, we have only 3% of our labor force are located in the high exposure group. Almost 50% of our labor force somehow employed in the middle exposure group. So this is I'm not going to spend so much time on this, but you see that there is no gender bias. Actually, age is one of the most significant predictor. Income and education are the most important demographic factors to understand the AI use. Then, using the same model, I add the creativity score. As you see, household ICT access, which is a physical capital for the information and communication technologies, and the digital skills. Anybody here? Power problem. Digital skills, it's kind of human capital that who have digital skills to understand computers and digital abilities. So all of them are significant and positive, which means that people with the high digital skills and high infrastructure are more likely to use AI for overall users, for personal or professional or economic formal educational users. So given the creativity scores, if any occupation required to have creative thinking are more likely to use AI. So this is kind of complementary hypothesis. So AI somehow complement what you have as certain kinds of occupation or certain kind of task that actually supported by AI, not somehow destroyed. But note that since we have only used employed people in this sample, it is hard to understand the replacement effect. Actually, we cannot see that AI may cause some kind of destroying job, but with this sample, I cannot say anything on this. But at this point, I can say that there's a complementary cases. AI complements certain skills, and those peoples are more likely to use AI. Then I add the high or medium or low exposure groups. So the low exposure group is the base. So these things says that whoever highly exposed as an occupation are more likely to use AI. The only exception is the formal educational users. So who are in the creative sectors as a occupations are not more likely to using the AI. That's something that there is some kind of substitution effect or something like that. Those people who have creative jobs are less likely to use the AI. Then I add both creative scores and exposure scores at the same time. At the top you see the point estimates. At the bottom you see the average marginal effects from the probit estimation. These numbers says that, for example, at the overall use case, creative scores means the 1% change, 1 point change in creative score, 1 to 2, increase the AI use by 3 percentage point, not 3%, but 3 percentage point, like 3 to 6, something like this. So it is very high effect. And it is true for all purposes, personal, professional, education purposes, the AI creative scores increase the AI using. As you see, if occupation is highly exposed, in this case, personal use, yes, positive effect, but at the professional use, you see that the people who are in the occupation exposed highly are not likely to use the more AI. But as I said a couple of minutes ago, most people are in the medium exposure cases. Only 3% are actually in these cases, so it may not mean anything. But at the last column, you see minus 25. It says that in this case, people who are highly exposed to AI are less likely to use AI by at least 25 percentage points. This is huge effect, and somehow in this case, this might cause a problem. At least since we are in the educational sector. For the household ICT access and the digital skills also having the same impact and still having the positive impact. So what we have, basically age is the most important factor using considering the probability of using AI. Gender case, there is no gender bias. Basically, it doesn't matter female or male in the case of using AI, both uses at the same level. The only exception is that if you are using the educational purposes, female are more likely to use the AI, male the less use. Universal education being in the Istanbul and being in the top quintile is the best, is the very strong predictor of AI use. Considering the access to ICT, access to digital infrastructure and digital skills are mostly positive impact and fundamental prerequisite for the using AI. Again, for the creative scores and exposure risk, if I include them at the same time, both are significant, which means that people who are in the highly exposure occupations are more likely to use AI, but at the same time, if your task somehow requires certain creativity skills, also are more likely to use AI, something like this. So basically, our results support the complementary hypothesis. So AI, at least, we don't see that much negative effect, like destroying jobs and everything, something like this. Given that almost 50% of the Turkish labor force in the middle exposure group, it is a good result. We don't see that much displacement effect, at least with this 1 year cross-sectional sample, we cannot see this. And demographic effects are important for the using AI, but also the other human capital and physical capital in terms of digital world are also important. And also, exposure risks is another important idea here. So, one last thing, we have some limitation. Of course, these descriptions, all net descriptions are basically done for United States. I've done this for Turkey, but this is the best data and nothing we can do more it because there are many people using the same data for many countries, something like this. So, one last thing, this is the high occupational exposure by age. You see if you're in the 40s at the top exposed. If you're getting older or like younger, you see less exposure, something like this. Thank you very much.
Thank you, Professor Halit, for your presentation. I'd like to invite other speakers in this session to receive questions. Is there any question in the audience? I will start asking first question, then I will ask Professor Ercan Özdemir that you said future is there will be no need for professors in the higher education institutions. How about how do you evaluate the higher education institutions? Are they ready and they are preparing for this future, and their academics, their students can take this transition?
Okay, thank you very much. I didn't mean that there's not going to be any professors. I meant that the professors are not doing the same thing as we are doing today. Let me just clear this up. And my professor has an article published about 5 years ago. It's only a single page. The title is "Bu Robot." That's the title. "Bu Robot." That's the professor robot. And the first sentence is that if you are a professor at the university, you take your heads in between your hands and think about your future because there is no future for the traditional professorship. That's the first sentence, only a single page. I can send you this article if you like. I have translated it into Turkish there. There will be a kind of a professor, but the professors are not going to be teaching, but they are designing the educational systems and trying to mentor the people who are the students. And the Turkish higher education system is actually making every effort to get ready for that time, because I see there is no way that every education system will transform after 2030, which is 5 years ahead. So I know that some studies are going in the Higher Education Council, and I'm sure in every country they are doing the same thing. The classes, first of all, should transform. The environment should be transforming. In 2030, there is a kind of an estimation. The biggest company ever in the whole universe is going to be a university over internet with millions of students. That's the estimation. You got to get ready for that. This is inevitable. We have to get it ready. We have to be actually, preparing ourselves to those futures. Either we're going to do it, or we're going to just transfer the knowledge from the outside of the world. If you don't manage the technology comes and manages you. That's as simple as this, sir.
Thank you very much. Is there any question?
Possible to add a little bit to this?
Of course, yes.
From different angle? Yes,
I would be happy to hear.
yes, really, I fully agree with you. Yes, to be able to see all of you guys, I mean, I'm not hiding myself. So that's the point. Anyway, so really to make a couple of points in here, really I agree, because this, we have been into a formal education. So this is being changed into informal education. And this is going to bring a kind of customized education, as Ercan Hoca mentioned, customized education which will bring modularized education. So it is not going to be anymore, we need mechanical engineering. In mechanical engineering field, you have over 1,000 sub-fields. So what will happen eventually? So there will be even, really education getting into more specific, modularized, and what we are going to be using, agents. Agents will be used in those specific fields to educate. So AI agents. So who is going to coordinate? Probably if we have human beings around, to be able to coordinate these efforts. So that is really the catch. The other point is really going to be about, because the question is coming up always everywhere, do we need to patrol AIs or humans, especially, now what we do, we put, let's say, specific rules and regulations over people, but what about AI? So I think we need to change the strategy or make it a dual way of, really managing it. So I think this is going to be another important point. So one final, of course, this AI, that's why I was calling whether or not it was from tool to threat. And there was a news on the internet, I even cut that news. AI coach two kids to commit suicide in California. So it is a big court case, and now they were trying to handle this, and they didn't know whom to blame. So you see, we have such a threat as well, that is very critical. Anyway, thank you.
Okay, thank you very much for your contribution. If there is not any questions from the audience, I will just ask a very small question to Sinan Hocam. You are using AI tools in your department, but how wide it is used in Gebze Technical University? For example, in engineering departments, are they all using AI tools to teach students? Is it, you can take this.
Okay. Thanks for the question. Unfortunately, no, this is just, we are testing some ideas, and there is big resistance actually. I mean, it is not just AI use in the assessment of the student, it is AI use in the classroom. I mean, the approach is kind of, the students will learn AI tools, and I know what I know already, so they will be like a mechanical engineering using AI, but I don't know AI, and I don't like to learn AI. So that's kind of the approach that we are trying to deal with. I mean, as George said, I mean, if you don't adopt, the technology will adopt you, and that will eat you. And academia is someplace where people are really, I mean, I am criticizing myself here. We are really conservatives. I mean, we don't like to change. Because I spent 30 years on this area. I'm not going to change the way I do my research or teaching, right? Yeah, so that's what's happening, but it's going to change once the people start realizing the benefits of it. Of course, there will be challenges and there will be problems. We have to deal with them, but the only thing that we can do is close eye on AI and try to do whatever we were doing like 20 years ago, 10 years ago.
Thank you very much. Professor
I just want to make an extra comment. Being a pioneer is not easy, really. It's a very challenging. You got to make all investment by yourself alone. You got to face all the challenges, all the resistance inside the enterprises or community. It's not easy, but I am sure, I'm pretty sure, there are so many companies now working on generating agents. And in 2027, 2028, there will be thousands of agents coming out, and you will only be paying just a dollar to get a single agent working for you. Now, if you want to develop that dollar, you got to pay $10,000. But after 2 years, you will be only paying a single dollar, even sometimes later 10 cents or something like that. But there will be thousands of agents available for you to form your education system. And I'm sure some of the AI companies now, they are intentionally announcing that AI is dangerous and so on and so forth, but they are developing agents behind to be on the, having a competitive advantage. They are actually preparing the systems. And I am sure there will be education systems, virtual education systems, virtual labs, virtual mentors, agents as instructors, capable of teaching the same topic in different ways to the different students. If I remember, I was doing a research, 10 years ago. I just learned that there are 11 patterns for a human being to learn. Every human being is actually having a single pattern of learning. And there are 11 of them. Maybe there are 15 of them now, maybe a lot more than, There was only 11 at that time, sir. I don't know if, I have to do the same analysis again, because that was, the research at that time was actually trying to, measuring the performance of the students over a distance-based education. That was the study. My PhD student was doing that. We found out that at that time, there were 11 patterns. Anyway, even if there is more, it doesn't matter. If you can do 11 patterns, that would help to the society. Anyway, I am sure there are plenty of agents coming, and then we shouldn't worry about the technology or infrastructure. Thank you.
Thank you very much. Yes, please.
Hi. Let me introduce myself first. I am a teacher from math, not from academy. I want to ask such a question. We as teachers try to integrate AI in our teaching math process, but how can higher education institutions better partner with our education institutions to prepare our students to be more effective in using AI, or maybe to ensure a transition from early AI exploration to advanced AI creators? Is it possible for higher education institutions to have a partnership with our education institutions to create a conscious use of AI among students? Because as far as I observe, our students are not good at using the AI. They are not ethical or conscious users. So what can be done for such a situation?
Okay, thank you very much. Hocam cevap vermek ister misin?
Shortly speaking, if I get the questions right, so education is not only higher education, right? It's an integrated educational system, starting from primary school, even pre-primary school, up until the post-graduate studies. So we have to consider them all. And AI is not touching only higher education. It is touching to the students, to the kids. My daughter is a medical doctor, and she says that when there is patients coming in, they ask the questions to ChatGPT. Bloody hell, what's going on? So awareness should start from primary school, to my understanding. Awareness of AI, awareness of, and also the education should be actually developed as in an integrated manner by official bodies implementing a strategy. I think there is a need for an educational strategy for the future. I mean, the educational strategy of 2030 is from the pre-primary school up until the postgraduate education. If we can have a strategy actually taking the overall picture, then it is easy to get it into the objectives of a primary education, objectives of a secondary education or high colleges and universities, and it is easy. But there is a need for an umbrella strategy to actually create a sustainable educational system aligned with the technological progress and societal progress. Thank you.
Thank you for your answer. I want to make something else. I think in Turkey, there is a big gap, or maybe I can say higher education institutions are a bit isolated from the lower education institutions. There isn't that collaboration between them as far as I see. How can this be established?
Yes, that is a big discussion. Maybe should be done in elsewhere.
If you are here from Ministry of Education, that means we are started to get in touch, okay, to get in line, right?
Okay, I think, is there any, okay.
Two points to that. One is going to be the online education. Right now, I don't know whether or not we have checked, there is EDX, WWEDX, and I think either net or home. So what happened, over 60 universities, including MIT, Berkeley, and Harvard, all these, and also international and some other universities got together and formed this online education. Really, basically giving diplomas and certificates, and they have so many programs. They have over 10,000 programs, and they have been offering it, and they are ultimately targeting to globalize this education under their umbrella. And that's why we don't have any university yet into that, but this is also very critical to be part of this. No, it wasn't there, unless, during the past few months, they got into, but this is something they have got reputable universities really being part of.
Thank you very much, dear participants. I am signaled that we are over time now, so so I will present the certificates for the presenters. Then we are closing this session. Thank you very much for you all coming for the session. Actual session.
Still get actual session.
Hocam öne gelirseniz bir de.
Finally graduated. Hard work. Family photo, family photo. They are also half, by the way.
Distinguished participants, we will now proceed to the evaluation session. In this concluding segment, our distinguished speakers and academic leaders will share their reflections on the symposium discussions. International cooperation opportunities and the future of artificial intelligence in higher education. To the stage, please welcome Professor Muzaffer Şeker, President of Tüba, Professor Ahmet Nuri Yurdisey, President of Aassa, Professor Mehmet Emin Aydın, Tüba full member, and Professor Yang Li, Director of Aassa.
Thank you very much. Now this is the conclusion session, and we being told that we need to evacuate this room. So our time is very short. So I'm going to ask the speakers their concluding remarks in a sense. So I would like to start with Professor Şeker, President of Tüba.
Briefly and quickly, I would like to summarize the yesterday and today's sessions. Applications being implemented across different areas of higher education are truly promising. The examples shared yesterday and today by our panelists from various disciplines within the scope of this organization have clearly demonstrated that artificial intelligence is no longer merely a topic of discussion or debate. It has rapidly become a technology that is finding a practical applications and integration into our daily lives. At this point, okay. Yeah, now. At this point, I would particularly like to emphasize one issue. In the coming period, we need to transform projects developed at the individual and institutional level into broader regional and global collaboration more rapidly. It is necessary for whole countries and for institutions. I believe this will be not only facilitate the dissemination of good practices, but also strengthening a culture of collective production and cooperation. At the same time, such collaboration will contribute to more efficient use of the hardware and energy resources required by artificial intelligence systems. This is important not only from an economical perspective, but also in terms of sustainability for all countries. Dear participants, I would like to express my sincere appreciation to ASEAN Academies, Science and Societies, also InterAcademy Partnership and IMAN, as well as to all participating institutions, speakers, moderators, and contributors for their valuable support. And also, as a reminder, I would like to express that we look forward to receive your presentations as a full article to publish as soon as possible. Okay, thank you very much for all.
Thank you, Professor Şeker. Now I would like to give the floor to Professor Aydın. Your concluding remarks.
Thank you very much, dear President. I will just give one or two sentences about this AI in higher education. A few months earlier, we had a meeting with our Nobel laureate, Professor Aziz Sancar, with colleagues from Tüba. And one of the colleagues asked him what he is thinking about AI technologies. And he said they had a project in his lab, and they worked over 5 years to solve the problem. But later, similar problem was solved by other people using AI technologies only in couple of days. So AI is, of course, very helpful and put you in, one of the presenters told us yesterday that put you miles away, miles ahead of the colleagues who are not using AI technologies. So this should be integrated into higher education curriculum and education system, as well as the research and development system. But I think at the moment only we heard about colleagues or professors from computer engineering departments. They are using effectively these technologies, but it is not commonly used in the universities. So in higher education institutions, probably the people should consider this and make progress about this issue. Thank you very much.
Thank you. Yongjo Lee is the director of Aassa. Now he will give his remarks.
Yes, suddenly I was invited to talk here, but anyway, I just came, and I think this is a very exciting topic, artificial intelligence in higher education. And I attend many meetings, but also through my lifetime, I witnessed many innovations. But artificial intelligence is the one which really change our tremendous change in all the respect of our life. For example, I witness quality control, finance, but that's not just we can manage. But AI is for higher education. AI seems to be that it change our life, and I have been teaching over 40 years, but now after I attend this seminar, I feel like if I become assistant professor again, I'm not sure whether I can survive. But I think we should learn AI to do for our future, and I think Aassa should prepare, okay, forthcoming seminar on this subject, and also AI with robotics will change also tremendously in our lives. So we should watch this area, and Aassa will be very interested in keep doing this kind of conference. And I'm really full appreciate Professor Tüba and Nuri to organize this wonderful conference. Thank you.
Thank you very much. I'm going to be very brief. 10 years ago, I was invited by teachers for a conference, and I gave a talk, and the title of the talk was The Death of the Teacher. That was my prophecy. There will be no need for teachers. And today, as you hear, Professor'ın Ercan Üstemen and Yusuf Sinan Hoca, they kindly said that no, we still need professors, because they are professors, we are all professors, but actually what they meant, we will be redundant. But Professor Muazzam yesterday, when we had lunch, said that one thing AI cannot make is this Turkish baklava. So you better think about your future, especially young people. Anyway, joking apart, this has been a nice conference, and I learned a lot as a social scientist, so I'm not very familiar with this AI technologies, so I learned a lot. I would like to thank Professor Şeker and staff of Tüba for hosting this. Aassa and Tüba has always been collaborating, and I hope we will organize more conferences in Turkey and somewhere else. Zeynep is probably will make an announcement about lunch, I suppose. Thank you, and I would like to thank especially the contributors, and we will need your finalized papers, and Tüba will publish it. Thank you. Zeynep, you are going to make an announcement?
Yes. yemek anonsumuz var mıydı? Ben yapayım mı? Okay, we will have our lunch today on the same floor we had yesterday, -1. Okay? You have 1 hour to have your lunch, and after that we'll have a short city tour. Okay?